are going to install some sensors like a depth turbidity sensor in the wetland tomorrow. Previously, we just connected these two sensors on the same local board. And how do we fix it in the stormwater drain? We just use a pole here and fix the pole on the concrete wall, and then attach these two sensors using the screw or some nuts or something. So it's easy. We don't need to get into the pit. We can just knee on the top of the road, and then we just use a drill to drill it on. Quite easy. And then we can get the data from the stormwater drains. Even though we can put the concrete like pit lid on, the data can still be transmitted to the website. So that will be an easier method for installation, instead of what I just discussed, like dig a trench and fit the sensor in and have a cabinet. So this one is just 20 minutes. You can make all the things done. Also, we do some mounting in the wetland. And we put a sensor here. You can see here, this is a sensor cable. We use a cable tie to tie it on the sensor, on the pipe. And on top of that is a logger box. And we put a sensor here. It can measure the water velocity and measure the water depth. And on the top of the sensor box, there's a solar panel. So we don't need to worry about it at all. So we don't need to even change the battery. How do we install this one into the wetland? They are standing on the wetland. So we just make a pole and we use a hammer, tong, 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 and make sure the pole is standing in the wetland solidly and it's very stable. We just put the PVC pipe slide on, and then it's done. Last time we installed about 10 sensor packages like these poles in the wetland. 10 sensors. I just do a preparation like wiring up all the sensors and then make sure the sensor is fixing on the pole and do a programming. I used about 8 hours to prepare all the things. And one technician and we went to the field and using about just 1 hour to install all of these sensors in the wetland. This is for the load monitoring program. Because some of the sensors, these are two commercial sensors. This is called a Queensland turbidity sensor. It's produced in Australia. And this is a depth sensor. We need the 13 volts battery like power supply. But we also use our sensors, like the logger board, to connect them with some wires and a regulator or the relay. So we can voltage up from 3.3 to 13 volts to give these sensors power supply. What we need to do is just put a big solar panel on, and then it will continue charging the battery. As long as it got some sunshine exposure to the solar panel, it will start alive again. And this is our self-designed ring gauge. It's a low-cost ring gauge. The ring gauge can also be connected to the BoSL board, connect to the data logger. The ring gauge in the middle, there is a tipping bucket. So all the ring gauge has these settings. So actually they are flipping on the two sides. So if they receive some water, they just clip to this side. And then we count how many flips. And then if it go to another way, we just count another number. So it's just keep adding numbers. And when it flips once, the magnetic field will be changed. And our sensor can detect that. So after we know how many times it flips, we know how much water it's getting into this tipping bucket. And then we know how much rainfall we get. The base of the ring gauge and also all of these design wiring things, they are 3D printed. And the wiring is going to the bottom. And at the bottom, we put our data logger there. And the data can also be transmitted to the website. We use some commercial sensors, actually 4 different commercial sensors with this one. We install it in the field to see the data variation and kind of compare this data with the Meltwater, like the official data. Actually, it works pretty well. But the price is only about 10 times less than the commercial sensor. But yeah, sometimes it has some problems because we need to consider like even though the ring gauge, we need to do the maintenance. We need to clean the dust to make sure there's no clogging issue for the ring gauge. Otherwise, we won't get the accurate data. So actually, when we do the real-time monitoring, the ultimate goal for real-time monitoring is real-time control. For example, if we want to control the water level in the wetland, previously we need to check the rain gauge. Physically, people go there and then physically turn on the switch, and then like the dam will be open and drainage some water to the downstream. But now, because we have sensor technology, we have IoT technology, we also have the understanding of the relationship between the water volume and the depth. And now we also have camera. We know what will happen in the field, in the wetland, or let's say in the on the dam. So we know what the condition it is. We connect all of these things together, and then connecting to our website server. So we know if this water level reaches about, let's say, 50 centimeter or 50 or 1.5 meter, it automatically open this gauge. After that, when it's going down to below 1 meter, and it automatically close the gauge. That is a real-time control. So by using the real-time monitoring, we just add something, algorithm on the website to make sure it can make the real-time control delivered for this project. That is a real IoT of things in environmental monitoring, I think. So we can do that by some more innovative devices and low-cost devices to make this kind of thing not only delivered in research, but also delivered in the environmental monitoring project.